In the previous videos, we have discussed about first come first served scheduling, shortest job first scheduling. In shortest job first, we discussed non-preemptive and preemptive. The third scheduling is the priority scheduling. So priority is a number or integer which we associate with the process. So smallest the number, higher the priority. So whenever the process is being given higher priority, it will be given the CPU for execution. Under priority, we have two categories. One is preemptive and another is non-preemptive. So the problem here is starvation. So low priority process may never get executed if more number of high priority process there. So solution, so aging happens. As the time progresses, it increases the priority of the process. So first non-preemptive. So here we have the process A, B and then C, and the burst time is 8, 1 and then 1. And we have given the priority as 2 for A and priority 1 for B and priority 3 for C. So priority is a number associated with each process. So here smaller the integer, higher the priority. So this is the Gantt chart. So since B is having the highest priority, so it is starting at execution at 0 and it is completing at 1. And the next higher priority is A, and it starts its execution at 1 and it completes at 9. And the last high priority is the C, which starts its execution at 9 and then completes at 10. So this is the Gantt chart. So when we find the average waiting time, for average waiting time of A is 1, waiting time of B is 0 and waiting time of C is 9. So average is 3.3. The second type is a preemptive type of schedule. So here is an example you can see. So there are 7 processes are there, and then their priority is given in right from 2, 4, 6. Okay. So here we are going to minimal, smaller the integer, low priority. So it can be of vice versa. Higher the integer can be of low priority, or lower the integer can be of high priority. So now we have the priority 2 as low and then 12 as high. The arrival time of P1 and P2 we have mentioned, and then till P7 we have the arrival time and then corresponding burst time. And here we need to find the waiting time, turnaround time. So this is the Gantt chart. So each process will gets its turn at different time. So for example, P1 if it takes, it is arriving at 0, and then it is executing for next 2 more seconds, and meanwhile at the executing next time interval P2 arrives. So when we check the priority of P2 and P1, and P2 is larger than P1, so P2 starts its execution, and the time 2, one more process P3 comes. So meanwhile the priority of P3 is 6 and then P2 is 4, P1 is 2. So P3 is higher, so P3 gets its execution. And next P4 arrives at time 3 and it's having a priority of 10, so it takes over the control from the P3 and it executes. And next P5 arrives at time 4, and when we compare the priority of P5 and P4, P5 is lesser than P4. So what happened? P4 continues its execution for one more time, and at time 5 P6 arrives, which is the high priority. Value is 12. So it is the highest priority of all the process. So P6 turn gets its execution and completes fully. So its burst time is 4. So it starts at 5 and then it completes at 9. Next higher priority. Next at time 6 P7 arrives and then its priority is 9. Besides we have a P4 which is higher. So P4 gets its turn and then followed by P7 gets its turn and then followed by P5 get its turns, and remaining priorities of 6, 4 and then 2 completes its execution. And here we can see the waiting time of each process and then turnaround time of each process. Waiting time can be calculated from completion time minus burst time. So advantages, what is the average? So starvation. So it is a situation in which continuous arrival of high priority keeps the low priority in a waiting state. So the low priority process will starve and then they die. So in aging technique, what happens? We are just prioritizing of low priority. We are increasing the increase at every time interval. So the advantages of priority scheduling is higher job priority job gets first. The disadvantage is starvation. So low priority process never executes. To overcome this, we are using the technique aging, which increases the priority of the process. Thank you.